was it like Dana? I thought so. I was like, I don't know, that doesn't seem right, but thank you for correcting me. Okay, go ahead, you guys.
Kevin, I'm happy to kick it off since I have like the background on bottle.
Sounds great.
Okay. Alrighty, I will share my screen. Boop. Hey, can everybody see my slides and hear me? Great. Okay, so yes, I'll just briefly introduce myself again. Julia Curley, she, her. I am currently a postdoctoral researcher at the National Renewable Energy Lab in Golden. But in about 2 months, I'll be officially transitioning away from that job and spinning out a startup company called EsterCycle, which is all about recycling bioplastics. So I'll be talking about that today, but also because I thought it might be of interest to the group. Well, actually, Kevin thought it might be of interest to the group. But I'll be talking a little bit about where both of our companies started, which is something called the Bottle Consortium. So BOTTLE is the worst acronym ever made. It stands for Bio-Optimized Technologies to Keep Thermoplastics Out of Landfills and the Environment, which is not only wordy, but it doesn't even totally encompass everything that BOTTLE does. But this is what we call the placemat slide for BOTTLE. So basically it is, the whole consortium is just working on solving the plastics problem full stop. So approaching it from every angle, which includes a lot of analysis and kind of techno-economic analysis, life cycle assessment on the new technologies that are being brought online as far as recycling, making new plastics, as well as deconstructing existing plastic wastes, using more biomass in our plastic materials so they are more sustainable, redesigning plastics to be something we call recyclable by design, so they're more circular and also biodegradable, all of these great things. And it is a group of national labs, universities, and industrial partners all over the country. And we're currently trying to add the University of Puerto Rico as well, which will be really, really exciting. There's some great research going on there. And then I thought I'd give a quick highlight of some interesting projects, particularly some of our industry collaborations that we have going on right now. If anyone is interested in learning more, just shoot me, your question, your email in the chat, and I can connect you with somebody to learn more. So one project that we're working on, this is the royal we, I'm not particularly on these, but working with Patagonia to take textile wastes that they collect, through their return program, and use a bio-based extraction process to remove the dyes that are used in them and even recover those for reuse, and then have pristine, nice white fabrics which can be recycled and re-dyed and made into new textiles. We have a project with Kraft Heinz on redesigning the ketchup packet. I know the ketchup packet might not seem, I don't know, complicated, but it's actually an incredibly highly engineered material that has about 8 or 10 different layers of different types of plastics and other materials in it in order to maintain that perfect, ketchup without going bad. And so there's a project going on to replace all of these many materials which make them impossible to recycle and also definitely not compostable, and replace those with one material with a lot of different properties, which is bio-based and sustainable. I'll be talking about our collaboration with Amazon today, but a portion that I won't be addressing is redesigning packaging plastics. So we had this amazing researcher at Colorado State University who invented a plastic which is made from this plant called Angelica root. And it can be compared with low density polyethylene. These are films of the new polymer versus low density polyethylene. You can see they're basically the same. It can be rolled into films. It was really cool getting to use Amazon's machinery for that. And it's a plant-based, compostable, and recyclable alternative to low density polyethylene for films. And finally, something that I think is just truly fascinating is this collaboration called WaterPact, which is the Waterborne Plastic Assessment and Collection Technologies. We love acronyms. And so this is work involving sampling from a bunch of different rivers in the US, different places along the rivers, because you can have different plastic flows in the middle versus at the edges and at the top versus at the bottom. So sampling all these river water samples and looking for plastics, quantifying how much plastics, spoiler alert, it's unfortunately quite a lot. But yeah, trying to quantify the types of plastics, where they might be coming from. A lot of them we've learned are coming directly from the manufacturers of like raw plastic resin, because they'll still be in that bead form that you get raw plastic resin in. So yeah, they're working on a full report of this like really incredible effort. So that's just some examples that I thought were particularly cool and hopefully interesting. But yeah, like I said, happy to connect you if you want to learn more. So my project, which is soon to be my company, I guess, started when Amazon came to Bottle with their, Prime mailer that everybody knows and probably loves slash hates showing up at their door every day. Amazon was called out as one of the single largest contributors to ocean-bound plastic in the world, particularly because their branding is so recognizable. And these mailers, which are made of polyethylene, can be mechanically recycled primarily into decking through store drop-off facilities. And that is a great process and vastly extends the lifetime of that material. But once that deck reaches the end of its life, that just goes to landfill. Additionally, I'm sure we're all aware of the deleterious effects of plastic that ends up not getting recycled or landfilled, but in the environment, eaten by animals who then can't digest it and often die of starvation because their stomachs feel full. But there's no nutrition in there. And so they wanted to completely redesign their packaging to something sustainable. And what we wanted to think about on our side when we're thinking what this could look like is we want things are depolymerizable, which is our way of saying recyclable in a circular manner. So we can take this prime mailer and at the end of its life, recycle it and turn it back into a new prime mailer forever, or any other packaging, of course, not just Amazon. But also we want something that is biodegradable, compostable, and more sustainable if it does end up, not in a recycling bin, but instead in the landfill or, unfortunately in the environment. And so the strategy that we came up with was to change these packaging materials from polyolefins, which are really hard to recycle, to something called a polyester, which is just the word for the chemical bond that holds these plastics together. And these can be much more easily recycled using the new technology I'll be talking about today. And they can also be composted in many cases, not in all cases, but in these new ones that we're designing, they can be composted and degrade much more rapidly to benign compounds in the environment. And that is a great backup plan, whereas recycling first is always our goal. So just a brief overview of what this technology looks like. We can take mixed polyester materials. So an example of what this can include is soda bottles. Our number one plastics are chemically very similar. They're polyesters. You can use some of these new like compost bags that actually composters don't really love too much usually, but those compost bags are polyester materials that can work in this process. All of the new compostable food packaging, single-use PLA, plant-based cups, all those materials like that can all be recycled together in this process. And we're actually breaking the chemical bonds that hold these materials together to get a sort of soup of building blocks, or what we call monomers, the things that make up the plastics. And so after you break all those bonds, we purify the compounds, get out all the dyes, all the additives, food waste, whatever else. And we get these pure building blocks that can be used to make new plastics with exactly the same properties as the materials did to start with. And so that's what we like to call a circular process. You can keep making new soda bottles or new cups or whatever it is over and over again. And part of the reason why people were so excited in our lab about this technology is that not only does it work well, but it is also economically viable. We've done some analysis showing that at full commercial scale, we'll be able to make recycled plastics for 31% less than buying new ones, which is very exciting because, as I'm sure everybody is aware, your process needs to be economically viable, in addition to sustainable, in order to really catch interest, in addition to reducing greenhouse gas emissions associated with making new plastics by almost 50%. So very exciting things. I'm going to actually skip this slide because it's not super relevant here. But this is just showing, again, examples of the materials that we've tested in the lab and work really well. So we did a collection event at the Denver Zoo, which was really cool, and got to collect these eco products, polylactic acid cups and coffee cup lids, as well as cutlery. There's all this new compostable packaging on the market, including by M&Ms, and this is a sub-brand of Pepsi that we can recycle. So yeah, it works pretty well, which is exciting. And so, you know, kind of where we see this fitting in and hopefully benefiting everybody is that a lot of composters don't want these plastics in their streams. They're not, you know, they don't think they break down fast enough. Like A1 Organics isn't accepting these materials anymore. But even if composters do accept it, they can often throw off their product because the plastics contain only carbon and oxygen, and it can throw off their carbon nitrogen ratios in the compost product. So getting those out of the composting streams will increase their product quality. For materials recovery facilities, all of these compostable plastics are currently considered contamination. Because they can end up in some of the other recycled plastic bales and lower the quality of those materials. For plastic manufacturers, we're hoping to be able to decrease, you know, costs and emissions while also increasing the sustainability for brands. Markets, you know, plastics are everywhere, for better or for worse. They're not going anywhere. So we really hope this can be a good solution for a lot of the plastic waste, especially as a lot of venues are switching to the compostable plastics to try and decrease their single-use packaging footprint. And we're looking at getting feedstocks, like I said, either from materials recovery facilities. Glacier is one AI robotic sortation company that we're talking to about the possibility of being able to sort for these materials. Amp Robotics, conveniently on the call, is another company that, yeah, I'd be really interested to learn more about whether or not in the future these plastics could be sorted together, baled at a MRF, and then, you know, sent off to be recycled, as well as from composters. So yeah, like I said, I'm very excited. We're not a real company yet. And by we, I just mean me right now. I will be the sole founder of EsterCycle, and I'm excited to say I'll be participating in the Westgate program, which is a startup accelerator that's housed at NREL in Golden. So I'll be staying in Colorado and aggressively applying for fellowships and grants to try and build a pilot plant here in Colorado, divert waste right here, and prove that this technology can work before moving on to try and scale up and further commercialize. So yeah, thank you so much, Allie, for asking Kevin and I to present today. I was very excited. And yeah, happy to take any questions now or later, as I said. So thanks.
Thank you, Julia. And congrats if you guys weren't at NextCycle, Julia won People's Choice. And I'm pretty sure I voted for you. So
Oh, thank you.
don't remember.
Yes.
This can hold me to that. We were sitting next to each other.
Yeah, NextCycle was also a super awesome opportunity that I would recommend to anybody involved in sustainability companies of any size.
Do you feel like you got a lot of outreach after NextCycle, like after you presented?
Yeah, I had much more than I expected in a great way. I don't know. I didn't know if anybody would be excited. I was like definitely the most scientific talk and scientific company. And so I know that can be intimidating. And yeah, so it was honestly really, really great to have people reach out afterwards, and to be voted People's Choice also was like, yeah, I was very touched.
That's what I hear about all the NextCycle. They always like come back and they're like, hey, I got like a big investor after NextCycle, so now I'm joining your membership. I'm like, oh my God. And there was like 8 out of 10 of them from last year. I think there was 10, maybe there's 8, but yeah, like all of them have been like, oh my God, look at me, I'm flourishing. Like, that's so awesome. NextCycle is amazing. So I'll let Liz ask her question.
So I had a couple of questions, Julia. One of the questions is based on what you just presented to us. It sounds like your technology holds the promise of allowing a wider swath of consumer packaging to be put into the recycle bin. Am I understanding that correctly?
Yes, eventually, you know, once like the MRFs would be sorting that and bailing it and sending it to us. Yes, absolutely.
And then in terms of the MRFs, I know you have some partnership with Glacier. Perhaps there's work to be done with AMP. Have you had a partnership with any MRF? Is there any MRF on the horizon that is willing to do a test case with you?
So I've spoken with a few people at EcoCycle, and I've been trying to reach out. I've had a tour, and I've been trying to reach out to sample, basically try and find out where these plastics are ending up right now. Presumably they would be sorted into their kind of like other bales, which are like numbers 4 to 7 for resin codes. But yeah, haven't heard back. So I noticed KJ is from EcoCycle, so maybe you could help me out. Oh, who have I reached out to? Shoot. So Chandra gave me a tour and she was amazing, and she connected me to 2 of the plant managers. Unfortunately, I'm not remembering their names off the top of my head. I think I have them written down.
Caitlin,
Kaylin and Cly. Yeah.
good. Okay.
Yeah,
Good.
and I had emailed them both, but have not a couple times, but haven't heard back. I'm assuming they're very busy people, so I don't take it personally. But yes.
We might want to put you in touch with Justin. Justin's kind of our business services manager, and he deals a lot with that stuff as well.
Sure.
So I have will you chat your email in
Yeah.
just because I missed it on the slide, and then I'm happy to make an introduction.
Amazing. Thank you so much. Yeah, really appreciate that.
And I guess Carling, you as well, if you wanted to, I don't know if there's any way you could work with AMP and connect with Carling.
Yeah, I was going to say, I wasn't clear if you already had talked to someone at AMP or if I could help facilitate
Well,
that.
I've talked a few times with Rob. I know he's no longer officially with AMP though, so yeah.
Sure. I'm happy to do so as well.
Okay, awesome. Thank you.
Look at that.
Great. Oh yes, yeah, and I'm sure, yeah, most of the film ends up in the landfill, I'm sure, but we can also take rigids too. So yeah, we're looking for any and all trash that people don't want that we can take.
Do you work with Ridwell with like the film?
Yeah, I've spoken with Rebecca is the
Yeah,
manager at the
Rebecca.
Denver location, right? Yeah, Rebecca. I've spoken with her a good amount about what that could look like. Working with MRFs will definitely be a several years down the line type of thing. For the smaller scale, we're thinking of partnering more with individual venues like the Denver Zoo, like concert venues, ski resorts, if they're using these compostables, like the possibility of having a designated bin or doing, collections, whatever that could look like. But yeah, Ridwell is another great one for kind of people who do Ridwell have signed up for it and are paying for it. So I know that their streams tend to be very pure because people are invested, which is amazing. And so that's also, yeah, a really good option.
Okay, thank you. My boyfriend didn't think we should do it, and I'm like, we're gonna sign up for Ridwell. Like,
It's
you
great.
know
I
how to
toured the facility in Denver. It was super cool. They don't throw out anything.
Okay.
Anything like there is like huge boxes of like wine corks that they're finding, like people who make art out of corks for, like everything has like a bin and it's going to a home. It's super cool.
Okay, convince me. I'll let Ringa say his question. Speak his question, I guess.
Yeah, hi. So this is really interesting. You mentioned specifically the sachets, the ketchup sachets, I believe, working with Kraft Heinz. So is that nearing commercialization? What is the status of that?
Unfortunately, that's still in the research and development stage. It's actually really difficult to do.
Yeah, I can imagine. Yeah.
Yeah, to keep something like ketchup fresh for, months at a time at room temperature.
Right.
So
Right.
yeah, still early, but they're
Okay.
investing a lot of money into it, which is great.
Right. And I think just to add on to Liz's question regarding the multi-layer films, I mean, as you know, that's impossible to recycle, and everything like our chips to cookies to fruits and everything comes in those kind of packages. And so is that, I mean, I know it may not be 9 layers, but if it's fewer layers, would that be easier to process? What do you think on that?
Using like our EsterCycle technology, The multi-layers that we've tried have been successful, particularly when they're certified compostable, because that limits a lot of the things that can be in there. And so the slide I showed with all the different packages, several of those are multi-layers. The chip bags have a thin aluminum layer, which most chip bags
Right.
do, but because it's certified compostable, it can only be very, 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 very thin. It's like 0.1% or something can be aluminum. So that's still compatible. A lot of the compostable materials have like starch or cellulose in them as a layer to aid in compostability and other, complex properties, and those still work fine. So, it is complicated because every single brand and every single product has its own special
Right.
formulation and everything, but luckily when something is going for certified compostable, that really limits what can be in there, and we found that works really well with our system.
Okay. Great. Thanks, Julia.
Thanks so much.
Any other questions for Julia? I know Liz has a list. She's just waiting to ask.
Anytime. Happy to answer.
So you said that the paper goods composting can throw that off. And I know that a lot of the composters in the Denver metro region are utilizing the compostable materials kind of as their, instead of adding cardboard to the compost pile, they're using the disposables. Are you finding, other than like the fact that it can't throw off and you have to have enough food supply to go with it, are there other reasons that like specifically that people would prefer to pull that out? I mean, is it that valuable of a product to like source separate it? Say we're at festivals and events, would we be dumping our food into a food waste and then the containers into a separate bin?
Yeah, great question. I think ideally we want to take as much of the burden off the consumer as possible, because the consumer at large is not always the best at doing their own separation.
course.
So for composters, there's technology called depackagers, which do what they sound like. They separate the packaging of food or whatnot from the organics. Not all composters have those. I know A1 was planning to apply for a forward grant for one. I'm not sure if that went through. But for us, it is very valuable. As great as having compostable plastics are, and we should absolutely use more of them because they are better for the environment, because they're used right now at smaller scales and they haven't quite caught on to the market as much. They're a lot more expensive than, like a PET soda bottle per pound. And so if we can get that material out and recycle it and use it again, that would be better. Additionally, there's some, pushback against them because sometimes they can be sourced from food crops. And, there's a question of, should we be using food crops for plastics instead of food to feed people? So again, being able to reuse that material is definitely better if possible. Oh, are you in Colorado Springs? Is the company you're working with in Pueblo Driven Plastics? Oh, they're great. I toured their facility. They're the nicest people and they got such a cool thing going on. It's awesome. They're putting
Yeah, we're
plastic waste in roads, basically.
super excited about plastic filmed roads and the Adamant Driven and Adamant Direct Polymers, and they're working on some combination stuff. I know we've got a project going on here at DIA where they're doing the pallet wraps and trying to figure out how we're going to get that shipped down there. So lots of flip film collection projects afoot.
Cool.
Okay. Any other questions for Julia? Or we can let Kevin go ahead and then we can do some more questions at the end, if that sounds good. But thank you, Julia.
Thank you.
Yeah, thanks, Julia. That was fantastic. And thanks also for the bottle intro. Yeah, so I'm excited to share kind of a different project that spun out of that same bottle innovation platform where we're developing all those technologies. This one highlights on kind of that more towards that first industry partnership that that Julia pointed out, where Patagonia invested in some of this dye recycle technology, as well as some recycling technology as well, specifically for textiles. And so about a year and a half ago, we were working on some of this textile recycling technology at the lab. It was working pretty well, and it got sort of to the point where we were like, okay, what's next? What are the commercial steps that we could take to really realize this? And as you all know, I think clothing is one of the hardest things to recycle. It's really challenging to do. Of course, there's a great repair and reuse economy, and there's more developing in that vein. And we've had lots of great connections to things like Goodwill. So 100%, if I could say one thing, it's, really support your local thrift stores. Buy used if you can. There's a lot of really great repair goods stores. I don't know about beyond the Denver metro area since I'm here, but there's Farrell, there's Wilderness Exchange that you can get really good outdoor goods. Farrell will actually repair your like tents or your outdoor gear if it gets a tear. They have repair people in-house that are actually pretty affordable. So just putting that out there for kind of the local reuse economy. But the problem is, if there's stuff that can't be reused, or if you donate something to Goodwill that no one wants to buy, what happens to it? A lot of it ends up directly in landfills. Something like 5% of volume sent to landfills is textiles. But a large amount after that is sent to other countries. So it's baled, shipped off to other countries, typically in the global south. This is a picture here on the left side of the Atacama Desert in Chile, where there's 20,000 tons a year that are dumped in the desert illegally. And actually, since this picture was taken, I learned that this big pile, it's all over the news. You can see it from space and everything. It actually burned down, which is horrifying beyond kind of conception. So, and the question is, why does that happen? Why can't we recycle them? Why can't we reuse these materials? It's a huge loss in a kind of linear system of an enormous volume of material. Again, a sad picture of the Atacama Desert with you can literally almost pick out individual garments. You can see, H&M, whatever, from these things. And it's about globally, it's about 100 million tons of textile waste that are discarded. Most of them end up in landfills or incinerators. And I don't even have a good feel for what 100 million tons of waste looks like. But that's, if you imagine, your trash truck coming to pick up your trash every week, it's about one entirely packed full trash truck every second that's landfilled or incinerated, just 24/7, 365. That's how much textile waste is being burned or dumped. And in addition to just like the insane amount of waste that is, the textile industry also creates a crazy amount of emissions, both in wastewater emissions. So it's responsible for about 20% of global water pollution. About 20% of all of the wastewater generated in the world is from the textile industry, as well as an estimate vary, but 2 to 8% of all CO2 emissions. So obviously it's a really energy and water intensive industry. And the fact is, less than 1% of all clothing is turned back into new clothing. And so that value that, whether it comes from a cotton natural resource where you have to think about all of the fertilizers and the land use and the labor and everything that goes into making a cotton garment, or synthetic garment where you have to start from like oil extraction and refining and chemical generation and all that. For that all to end up in a linear process where it just gets dumped or incinerated is crazy, and an enormous loss of value and a waste of resources. So obviously there's a huge and growing incentives to recycle these materials. And luckily, we now have some policies coming online in the EU, which are really, and some places like carpet recycling incentives in California, which are really spurring efforts and making real change in the textile recycling world. So I think it's a very exciting time. There's a lot of movement happening because people are recognizing the insane consequences of kind of increasingly fast fashion. But then getting to, why does this happen? Why can't we recycle them? We recycle other things. We recycle, packaging plastics in increasing amounts. But the problem is, unlike packaging plastics, where at least to some extent you can separate out, a PET water bottle from an HDPE laundry, detergent bottle. With garments, a lot of times they're physically woven together, right? They're within one garment. Your label on your jacket might say 100% polyester, but the zipper is a different material. There might be down inside that's a different material. There's dyes that are on it that are, a different material. So even those labels that say 100% are not 100%. And then you start, of course, thinking about what happens if you have a polyester spandex material, all sorts of different blends. And that makes it nightmarish to try to recycle. And so that's really the main reason why it's hard to recycle these things, is because they're so intrinsically blended. So that was kind of the problem that we identified when we were setting out with this project. Is like, okay, that's the real problem. Why can't they be recycled? It's because they're mixed. They have all these additives, they have prints, they have dyes, they have finishes, they have all these things. So if we really want to design an effective recycling method for these garments, we have to have something that is tolerant to the presence of all of those different materials, that then still allows you to recycle the valuable material that you want. So with this process, we're focusing on polyester. Polyester makes up 60+% of all apparel. The next most is cotton, is 20-some%, and then it's single digits for kind of every other material type. So the most volume of apparel products and fiber products is in polyester. But a great deal of that material has things like spandex in it. So something like 80% of all polyester is a polyester spandex blend, even if it doesn't say it on the label. And if that is the case, that is unrecyclable with any existing technologies. So that's been really our main focus, is on kind of synthetic blends, which is why we've interfaced with a lot of the kind of outdoor apparel brands. And that was the identified problem, is like, these things are unrecyclable. This is why. How can we address this? And so what we developed at NREL, and what we're spinning out now as Terraform, is a method where we're using bio-based solvents, as well as the oxygen and air, to help break down some of those contaminants, and then allows us to recycle that polyester in those materials. And the way I like to sort of visualize that is, if you see a piece of plastic sitting out in the environment for a long time, you'll notice it does get brittle, it gets yellow, it starts to break down in the environment. And that's actually mostly due to the action of oxygen reacting with that material. It just happens over a really long time scale, like decades to centuries. And so part of the concept that we came up with was, can we take that same process and instead get it to happen in minutes in the reactors instead of centuries? And so that was really the fundamental beginning of what we started with the idea of, that type of system we've shown can degrade a lot of these different contaminants, and then allows you to then recycle that polyester component in a full textile to textile recycled system. So to sort of give some examples, a lot of the substrates we work with are things like carpets. We get carpets from California, from their Cal Recycle program, through a company called Circular Polymers. We also take textiles, a lot of textiles from various brand partners that we've been working with. And we just dump them in this chamber where you're, in this case, the solvent we're using is just concentrated vinegar, essentially, acetic acid and water. And you pump in your air, and then you can add catalyst to speed it up. But then what you get is you break it all the way down to the chemical building blocks that polyester is made from, which you can then isolate and then make back into polyester, and then ultimately back into new fibers and fabric products. And so what we've kind of, the fun part of my job is we've tested kind of weirder and weirder inputs. We kind of go to to whomever, whichever brand or whatever, and we say, like, you know, what are you having a really hard time recycling? And then kind of engaging in some pilot projects with those brands. One example I like to point to is if any of you know Tersus Solutions, they're a textile kind of cleaning company. They manage, they're down Denver, and they manage a lot of the Patagonia and North Face's kind of worn wear programs where they do the resale platform. But they have a down recycling program as well. And so my car, the inside of my car is still, every time I open it, it's still full of feathers from the one time I went to go get a bunch of like down contaminated shells because they removed the down and they had a bunch of leftover shells that we took to process. But yeah, I don't think my car will ever not be full of feathers for the rest of its existence. But just to show you an example of kind of the diversity of things that can go in. So just to show you again for polyester, the way that the conventional material is made is you start with extraction from oil and gas. You go to all these different steps to refining and chemical production, and up to the spinning to produce yarns, and then fabrics, and then a cut and sew to produce finished garments, where it goes kind of through the brands to retailers to consumers to thrift stores, etc. And there's huge amounts of waste kind of at multiple stages of this process. So when you cut and sew, there's a pattern that you cut out, and then anything else goes to waste. There's a lot of waste loss from there. Retailers typically have a lot of overstock. That's kind of an unspoken about part of the textile industry, is they may only sell 30% of a given run of product, and then the rest goes to be destroyed. And so there's a huge amount of loss there. And then, of course, through other channels as well. So really where we see ourselves operating is being able to interact with a lot of those different sources of textile waste, because we can be pretty feedstock agnostic, breaking that down and then slotting back into the existing supply chain, but circumventing that oil and gas part. And I will note here, if you go to the store now, you can see plenty of garments that say, made from recycled content, especially kind of in polyester jackets, other things. A lot of that is, if that is the case, there's essentially 100% chance that what that is that comes from waste bottles. So waste PET from water or soda bottles through companies like Unify or Eastman or other things, which is great. I mean, it's still giving extra life to those waste products, but ultimately it's still linear, right? If there's no way to recycle those textiles that product goes into, it still is destined for landfill. And so what we really want to be able to do is close that gap to stop that linear production, whether it's from oil and gas precursors or from recycled plastic precursors or recycled bottle precursors. Yeah, so just kind of to highlight, I don't need to go into super detail because I think you all are pretty sophisticated. I don't need to teach you about what recycling is, but mechanical recycling, right, is where you think about physically grinding stuff. That's where a lot of the water bottle to textile processes lie. But really where we see this strategy, which we're calling oxidative, is in dealing with those mixed textiles with lots of contaminants. And so that's really what sets it apart. And like Julia said, it doesn't really make sense if it can't be cost competitive. So we've been able to leverage the resources at NREL. They're amazing economists and techno-economic analysis experts to show that the price of the material that we make, again, using this carpet feedstock just as an input for processing costs and purchasing costs, we can show that we can actually be cost competitive with the polyester price, with the virgin polyester price. And so that's really ultimately the reason we decided to start the company, because that actual commercial potential there. One thing that I think may be interesting to discuss for y'all is, in a recycling process, a lot of people consider like, oh, you can get the feedstock for free, like or like very cheap. It's recycled stuff. It's trash. That should be the easiest part. But in fact, that's that blue bar here is the overall contributors that goes into that cost. It's by far the majority of the price is how much you're actually purchasing that waste feedstock for. So if you're able to get lower quality feedstock and accommodate lower quality feedstock that doesn't require, that doesn't command a higher price, you're able to use a much more economical, or have a much more economical process. So that's why things like carpet are relatively cheap compared to something like a bottle flake input. Then of course, we have to make sure that the environmental footprint is lower than the existing systems. And so here, by leveraging kind of similar resources, we can show that relative to the petrochemical production of polyester, using this recycled system allows us to achieve significant reductions of both energy use and greenhouse gas emissions for the process. So where we are now is still, again, this came from kind of like brain idea concept to early lab scale to now we're sort of working on the scale up and deployment of it. So we're at the about 1 kilogram processing capacity scale. Within the next couple of weeks, we'll be kind of tripling that. And what we're looking to do now is scoping out an independent facility here in Colorado to scale that up to much larger volumes to where we can actually start making good amounts of fabric product, fabric finished product. Just our general pathway, the typical path for that, like a lot of brands typically engage with startups, is they'll do what's called a capsule collection. And you've all seen this. You know, Patagonia will say, hey, look, we have this t-shirt made from ocean plastics. We're selling a limited run online. And that's typically how a lot of startups interact with brands. And so that's our goal for our kind of pilot facilities, to be able to produce enough fabric products, enough garment products with a brand partner to be able to do that capsule collection. And so that's really where our primary goals are for that facility in Colorado. And then lastly, our team so far, it's just myself and my co-founder, Mike, who we met as postdocs at NREL. And then we've been putting together a team of incredible advisors that have been helping along the way, both for kind of the scientific continuation development, understanding the textile industry, and then teaching us chemists about how the business world works. And we've had the extreme fortune of being in a variety of kind of accelerator programs. Like Julia mentioned, this Westgate program has been fantastic for us. We're also loved the NextCycle Colorado. We did that a couple of years ago, and that was super valuable. And then we were lucky enough to get this innovation award from H&M called the Global Change Award, and recently accepted into this accelerator program called Venture for Climate Tech. So with that, I'm really excited to answer any questions you might have. And yeah, we'll take it from there.
Thank you, Kevin. Sorry, I forgot you were at NextCycle. Was it last year you were at NextCycle?
No, we were two years ago.
2 years.
Yeah.
Okay, I wasn't there, so that's why I didn't remember.
Okay. Fair.
Yeah. Yeah. Any questions? Feel free to go off mic.
Brian put a couple questions in the chat, Kevin, if you want to
Oh, great.
scroll back, and he had a couple of comments there that I certainly want to give him a chance before I start with my list of questions.
Yeah, let's see them in order. Bamboo, yeah. Let me see. Okay, yeah, bamboo. Yeah, bamboo is so there's a whole subcategory of textiles, right? That's they call it man-made cellulosic, and that's any cotton-based, like cellulose-based thing that is not from cotton. And so that includes a lot of things from, you'll see the bamboo, you know, tree waste, various biomass waste. And that's what makes up things like rayon and viscose and lyocell. Like those are the things that you will see that as. And there's still a lot of, so there's positives and negatives to anything in the textile industry. The way that those materials are created seemingly can be more harmful than making it from cotton, just in terms of the chemical processing that's required to actually extract that cellulose from some of those resources. There's improvements all the time, and so that's not a hard and fast rule, but generally, as I understand, it's both a very water intensive and chemical intensive thing to create some of those lyocell and viscose and rayon and et cetera fabrics. So, you know, the nice thing is that, you know, bamboo, for example, it can be grown very sustainably as an agricultural product, but then the processing that goes in is worse. So the problem in the textile industry is you're always balancing a whole bunch of different factors, and it depends, you know, what you care most about, and everything is sort of evolving as well. So that's what I'll say about that bamboo derived material. And for the second question, plastic bottle, hemp actually can be processed. It depends with the hemp. But if you're making a direct hemp textile from hemp fibers, that is actually pretty sustainable. The problem is that the feel is typically a lot rougher. It might have a smell to it, and so as long as you're okay tolerating that, that's fine. But for like mass market appeal, there has been less adoption of hemp because of, it's just a coarser fiber than cotton, so it's harder to make it feel nice and cozy. But it's great if you it's great in a lot of products, especially things like canvas bags and other things like that. Like a lot of those are hemp derived, and that's fantastic. See you next month. Thanks for joining. Yeah, so then the microplastics question, and that's an excellent question. And the answer is, this is not a microplastics mitigation process, unfortunately. As you correctly point out, microplastics like polyester, nylon, all those synthetic plastics are a major contributing source to microfibers and microplastics in water systems. But the thing is, polyester as a percentage of amount of textiles is only increasing year to year. And so I don't like that polyester is most clothing and is continuing to be more and more of a share of clothing, but unfortunately that is the reality. And so what we're addressing is being able to recycle that material, prevent that waste product from going into a place where it makes a lot of microplastics as well, illegally dumped in deserts and in waterways and other things, by closing that loop. So we're not addressing the microplastics problem, and that I wish we could. That is a separate challenge. But the reality is that the polyester market is continuing to grow in fiber industry. So the expectation is that that's going to only increase. And I would, like with the hemps and the other things, I think alternatives are great, and you should buy alternatives to plastic textiles when you can. But unfortunately, that, like I said, the volumes of those waste products are only going to increase. And so our challenge is to deal with that waste stream. Julia.
Hi. Okay. Yeah. Sorry. It's a follow-up on that. I think the question of like polyester and other synthetics contributing to microfibers and microplastics is so interesting and complicated, because I've also most life cycle assessment that I've seen has shown that synthetics are less emitting and not necessarily more sustainable, but take less energy and less water to make than something like a cotton. And so I don't know, how do you kind of think about that as far as what is better, or like, yeah, I don't know. I'm sorry. It's not really a fully formed question. It's just complicated.
No, it's a great question. The thing is, better is really, really, really hard in textiles because, and I'm sorry, I do have to hop, I have a hard stop at 1, but if anyone has any further questions, I'm super happy to always talk about textiles. With that water pollution amount, nearly all of that is from the cotton industry. In the dyeing process, especially for cotton, probably the majority of this number is from dyeing cotton. And so it's extremely challenging to think about better. The best thing to do is all is bad. And so reducing consumption, increasing increasing reuse options, repair, that is the best way. There is no better, because even for the microfibers question, cotton is cellulose. When you dye cotton or finish cotton to make it processable or whatever properties you want to give it, you're actually chemically modifying that cotton. So it's no longer cotton, it is some synthetic product that's derived from cotton. And what's found is when those microfibers go out into the water systems as well, there's a huge difference in terms of how biodegradable they are based off of what finishes have been put on, what dyes have been put on, because they're actually chemically modified compounds. And so for that microplastics question, you know, for all the questions in terms of what's better, it's a really, really nuanced discussion. And I think there is no better. There's just local optimizations in terms of what you care most about, whether it's water pollution, land use, et cetera, et cetera, et cetera.
Kevin,
Sorry, that's not a great answer.
do you have like a chart or maybe a resource that would compare all the different options?
Ooh, great question. I can
You have to
think
leave,
about
but
that
you
probably.
can
Yeah, I
email
also
me.
have to leave, but yeah, I'll email you some resources about that.
Okay, cool. That'd be kind of fun. I know that's like, what can be recycled? People always ask us
Mhm.
that, and we're like, we don't have a hard resource on that. So totally get
Yeah.
it. It's also hard. Cool.
And a lot of it's in development. The textile reuse and recycling is just not developed yet. Anyway, thanks so much everyone for the opportunity and great questions and discussion.
Yes, more questions coming your way, I'm sure.
Sounds great. Thanks everyone.
Perfect.
Bye.
Thank you, Kevin. Thank you, Julia. I'll post the
Thank you.
recording so you can share it out. And then I'm going to post all these resources, I think, as well, so we can share our BIPOC resources. Cool.
Awesome. Thank
And
you.
yeah. And if you have any questions, Julia, you put your email in the chat and I'm going to put Kevin's
Oh
online.
yeah, I'm sure he'd be okay with that.
Yeah. Yep. And then our next snack and share will be, I think, with Anheuser-Busch talking about their glass collection project. So that'll be pretty fun because Liz and I have been working with them to get some bins on the ground, which has been a fun process. All these recyclers want to commit and then they don't want to get a bin. I'm like, but it's okay. Cool. Well, thank you guys. Enjoy the rest of your week.
Thanks.
Thanks.
Thank you, Ellie.
Oh, there she goes.